When dealing with forces, we have to look at them as vectors, remembering that vectors have both direction and magnitude. We've dealt with this before when we talked about displacing ourselves. So when we did that vector walk outside, you had walked 3 meters to the right, 3 meters to the right, north, south, east, whatever you did, and then we found displacement. So in this example for number 1, we have 3 squares to the right and another 3 squares to the right. We simply add those two vectors to show a total vector of 6 to the right. In the same sense, we can almost break a vector that's bigger up into two small ones. So this vector is a total of 7 to the right. And we could say that's almost like doing 2 to the right and 5 to the right, because 2 plus 5 in the same direction would get us 7. Instead of breaking vectors up that are in the same direction, we're now breaking vectors up that are at angles. And we're breaking it into its horizontal or x and vertical or y components. So for this part, we're looking at how does this vector go? If I had to describe the vector, I would say it goes to the right and up. And then even more specifically, how much to the right and how much up did it go? So we can just simply say I went 4 to the right and 3 up. So just like this vector, 2 plus 5 was equal to 7, now a 4 to the right and 3 up is equal to this angled vector. So that x vector of 4 plus that y vector of 3 gives us the resultant we see right here. You could do the Pythagorean theorem, 3 squared plus 4 squared equals c squared, and solve for the value of that. But right now we're just going to look at the graphical meaning of these components, not necessarily mathematical. For the next one, it shows that the vector is going down and to the left. Or we could say to the left and down. It doesn't matter which order we say the directions, seeing as I could draw it first to the left and then down, or down and to the left, and I would still get the same values. So I'm going to go ahead and go down. And we went down how many? We went down 6, and then to the left, 3. Why don't you go ahead and try the other 4? Pause the video and then check your answers after. For 5, we are looking at 6 to the left and 2 up. For 6, we're looking at 3 down and 7 to the left. Oops, sorry, to the right. For 7, we are looking at 7 up and 4 to the right. And for 8, we see that we are going 2 down and 9 to the left. So breaking up vectors into their components is as simple as making it into a nice right-angled triangle with your x and y components. Remember, the x components are the horizontal components, and the y components are the vertical components.